Okay, there seem to be two popular answers, either 4 or 8. Okay, the electric field, so let's think about what 4 and 8 mean. 4 is a force pointing that way, and 8 is a force pointing that way, right? So everybody believed that the force is going to be in one of those directions, but how do we determine which? Well, remember that we have this equation F on particle 2 is Q2 electric field due to whatever it's due to. And we saw that if we put a proton at some location, because Q for a proton was positive, the force was in the same direction as the electric field. What's the sign of the charge of an electron? Negative, right? And so we get the force vector is the electric field vector multiplied by a negative number, and that switches every component of that vector. So therefore, the force on an electron is indeed opposite to the direction of the electric field. So good for those of you who got it. And one of the messages here is that this vector equation actually has a lot of information, and it looks like a really innocent little equation. Okay? Really doesn't look like much. And yet, it tells you a lot about the direction of a force given the field, or vice versa. If you know the direction of the force on a particle and you know the particle's charge, you can figure out the direction of the field. Okay, quickly, let's try this one. At some location, location A, there's an electric field, and the electric field is such that when you place a proton at that location, you measure this force on the proton. Okay? Can you figure out as a vector what the electric field is? Remember that the charge on a proton is 1.6 times 10 to the minus 19 coulombs. That's the charge on a proton, plus E. Okay? So you might even be able to do that one in your head without a calculator. Here's some possible answers. Okay, well, we definitely have a popular answer. Now, how do we do this? Let's remember that this vector equation really tells us a lot about the components of these two vectors. It tells us the x component of the force vector is equal to the charge times the x component of the E vector. The y component is equal to the charge times the y component, and the z times the z. Well, the charge is not 0, and that certainly tells us that the x and z components of the electric field must be 0, right? So we've only got a y component. The force on a proton was in the negative y direction. So what does that say about the direction of the electric field? Negative. Okay, so it better have a negative y component. It better have 0 x and z components, and there's actually only two possible answers. This one, you forgot to take into effect the fact that there's this q here, right? So you have to divide by q, and so I believe that 4 is the right answer. We have negative 4.8 times 10 to the minus 16 divided by positive 1.9 times 10 to the minus 19th, and we get a negative 3 times 10 to the third newtons per coulomb. Okay?